Okay, guys, hello. We're starting the day number 4. Today we keep going, we keep watching live coding. This day we're going to explain Rust, write the smart contract in Rust. So go ahead, Juan, whenever you want.
Thank you. Hello. First, I wanted to show just something about the testing in assembly script, and nothing too big, just to reinforce this. I'm opening the project. I want to dedicate almost all this hour to Rust, but just this example. How the testing works in the example that we showed yesterday. Well, I mentioned it that before each will be run, before each of one test gets called. So let's write one just for show you how to edit this. Let's erase. So we want to create a simple test. Current account ID is greeting. The signer is Alice. Okay, so let's push a message. This message is saying Awesome South. And then let's create the test. It is the amount of message should be 1. The function this is. And we wait, and the length of messages will be 1 because we are sending just one message. So let's test if it works. This is the new test with the green check mark. The amount of message is 1. This is a very simple explanation about the, or example about the testing in assembly script. We are going to dedicate to Rust today. Why? Because this is less verbose Rust, and is with the very basics that you know about assembly script, about the typing and this. Rust is it's similar.
Yes, but I find out Rust very straightforward.
So let's create a new project in Rust.
Can you explain how to start Rust?
Yes. Close folder. Okay. You can see still my Visual Studio, right? Ah,
Right.
yes. Thank you. Ay, trabo. Aquí está. Yesterday we installed Rust with the default configuration. That's perfect. We are going to create a new project in Rust with cargo, new, lib, and let's write a name, near course. Click enter. And cd near course code in a dot, and we'll open the new Visual Studio. You don't see this.
Juan, please explain the basic structure that project in Rust generate when we start a new project. That is very simple. We have source and a file called cargo.toml that has all the necessary libraries to work with. And we need to add the near SDK here. That will be all the dependencies. Go ahead, my friend.
Thank you. Something can internally use near is the type of library is a right type cd yd. This is something that we don't need to worry about. It's something internally about how it links the crates, but it's necessary to add this line. Then in dependency, we are going to use the near SDK with the version, the latest version is 4. Now we need to add another property that is profile.release. And this makes a little bit slow the compilation process, but at the end, it gives us a minor storage contract. So let's write this code again, unit 1 of levels C. This is the same for, we are not debugging the release version. If the contract panics, it will be aborted the call. And something important, the overflow checks. Like we said, if we have an integer 8, this will throw a panic if we try to write something like 10,000, because this is not possible in an integer 8. We'll see a file called lib.rs. We don't need this function. And Now we'll see the very basics of a smart contract. Like in assembly script, you need to import the necessary that you are going to use. We are going to use the near SDK, and from inside we are going to use the ENB. This is the information about the blockchain, like was context in assembly script. Here is called ENB. For show you, ENB could be used. I will not show here. Great. ENB has the next properties: the storage price per byte in the blockchain, the account balance of the caller, the account locked balance, the deposit attached to the call, the block height, timestamp, the current account ID, so the ID of the contract. If the account ID is valid, and the promises, and a lot more. Then we are going to import to the near Bingen. This is a macro that we need to serialize and save the contract in the blockchain. We are going to use the Bolsa storage key. It's for the same, for serialize the storage key. The account ID, this is a type. Panic on default, or contract can't be called without an implementation, and promise. From Borge, we are going to use Borge itself, Borge the serialize, and Borge serialize. Borge serialize, where? We're going to create a constant with one near, that will be an unsigned 128. Like we said yesterday, the near is 1 plus 24 zeros. That's why we need an unsigned 128.
Remember, it's Yoctonir, guys. Always a near is represented by one Yoctonir.
One Yoctonir is this, and one near is this. And we need to create the structure of the contract. We create this with the macro near binden. Now we need to add the boards serialize, and panic on default. Those are imported here. And we create the structure with public struct. And we can call it contract or whatever we want. So course example. We can add the owner ID. That will be the type account ID. That's why we imported it here. And in this example, I want to create a contract that store deposits. So you can send it and withdraw it. So storage deposits will be of type unordered map, account ID, U128. If you know another languages, an unordered map is something like a hash map. So you can send the information is stored with key value. So you can store whatever you want with this structure. Key value, another key, another value, and so on. So an unordered map is a hash map. We are saying this error because we have not imported the unordered map. Use near SDK collections. Unordered map.
Yeah, so you can see this special variable is not from Rust, is from the near SDK.
I was imported here. Why? Oh, the D. And then we need to make the implementation of this structure. So we are declaring in the structure what we want. We want a field called owner ID that is a type account ID. So I can tell the contract I am the owner ID. So maybe you create something variable that needs oh, you are the owner ID, just you can update the contract, or just you can withdraw to all. If you are not the owner ID, you can do this. That's example of the use of owner ID. And another field of type with name, storage deposit of type unordered map, key, account ID, value, and number unordered consigned 128. Then the implementation needs to the near binden, and we create the implementation with impl, the same name that you choose. Course example. And now we add an init function. Why we need an init function? Because we need to create this map. This will be created something like empty, but will be stored in the blockchain. And you need to add the owner ID. So the init function, it's called with the init label, and we create public function new. This returns a self, so the contract itself, and the function will ask with assert the state of the contract don't exist. We can continue with this call. Let's disable this.
This copilot everywhere programs very good.
So if the state exists, don't exist, we can continue. In other case, the contract is already initialized. And then we continue with this function. We create a self. This is telling us we need to add the owner ID and the storage deposits. How we say the owner ID, I can read here my account ID, or like we have the PNB, we can say the owner ID is the signer account ID. So I will call this function, and the contract will know that I'm the signer ID. I'm the owner ID because I'm the signer ID. Now we need to create the storage deposits. This will need the another thing that we imported, Borch storage key. We will create here and then an enum with the right Borch storage key and Borch serialize. Public enum storage key storage key, and the key will be whatever you want. Let's call it storage deposits. This will serialize this to the to something like a hash, so this map will not collide with another. Suppose we have multiple maps. If we choose a different key, this will never collide.
Can you explain a little bit how is a storage deposit and how it works and what we need to implement this variable in a smart contract?
Yes. Let's create this unordered map. New. The prefix is the storage key of type storage deposits. And with this, we have created yes, itself. What? Why this error? Contract is already initialized. Oh,
There is one question. What is Bosch serialize? The serialize.
what is Bosch serialize and deserialize?
Yes.
Mm. Bosch is like when you serialize a JSON in another language. Bosch is the same. You need to serialize to Bosch that is simpler to near and another blockchains to understand, and you need to deserialize from there. O sea, then everything you send should be serialized with this kind of
Type.
yes.
And what is this for? What we need to serialize and deserialize because it's compiled?
It is
Or is to keep alive,
internally.
or is to keep alive the data through the blockchain?
Yeah, the blockchain internally has everything serialized in boards. That's lighter for the blockchain.
Okay.
That's why we need to serialize to all the information.
Okay.
Let's create the functions to see this working, and let's try this. If you please write in the comments if you have the near CLI already installed, so you can try it when I deploy it. Then let's create a function. This kind of function will be variable. Why we need to add this word? Because just the function that has this label can accept deposits. If you send a near to a function that don't has this, the contract will the call will panic. So public function deposit to storage. In Rust, you will see that we can add self, amper self, amper mod self. Why? Self will read the information of the contract, but if you need to modify the information of the contract, you need to call with mutable self. So this function will ask if attached deposit it's more than one near. If not, then we'll say deposit must be greater than one near and panic. The deposit is it's greater, then let's continue with the function. Create a variable inside the call. Call it account ID that is of type account ID. That will be the signer of this transaction. And let's create a variable, call it a deposit of type unsigned 128, and this will be the attached deposit. And let's create a log that will be the transaction receipt. The message will be formatted. Format with let those join strings. So you have deposit near. These curly braces means that you are going to join a string there. The string you must insert later than a comma. This will be deposit divided in 1 year.
Where this variable 1 year comes from, Juan?
1 year is the constant that we created in the first.
The first, okay.
So if you said 1 year, because we are telling here you deposited 1 year, not a million of octoneers, you need to divide. If the deposit is equal than this, divided into equal than this, then you deposited 1 year. If you have deposited 10 years divided in this, you use the right amount of near. But you can say the deposit, and this will give us all the octoneer. But more readable to say this. Then we are sending a log and so, but we are not storing this on the blockchain yet. We need to call self storage deposits, insert. What is the key? The key is the account ID and the value is deposit.
Okay, there is when the blockchain can be confused, because we need to know, okay, when we're going to store data in the blockchain. That's when it comes the pre-built functions on here. As you can see, you don't need to worry how to insert the data. You just call the function insert, and you add 2 parameters. The account ID, that will be always the signer, okay, the guy who is logged with their wallets, and of course the value you're going to deposit, that will be the unordered map. Okay, why Juan is creating this deposit storage function? Sometimes when we are in data to the blockchain, we need to add more nears to cover the storage. Okay, as you know, nears, the fees they charge for fees and storage for each transaction. Not only near, all the blockchain like Ethereum, like Solana. This is the way they earn money. Okay. Charging for fees for gas. So this function will help us to add more storage to our smart contract when you're going to load a lot of data and the available amount of near you have to storage is not enough.
Perfect. And now maybe you have a lot of deposits here. and maybe you want to withdraw something of this. So let's create a function that don't need to be payable. And call it withdraw.
Yes, you call payable function just when you need to add or yeah, you need to add money to the smart contract, or you need to charge to the user to pay something for any task.
Yeah, but now the contract is the one that will send you your money. Obviously, this could be added more this, because the storage will require a little bit of gas charged to the smart contract. So maybe, yes, you can ask for a little bit of payment here, something like 0.0001 near. But this is something more complicated that you don't need to worry about in this course. But if you are going to create a decentralized application in here, you should worry about perfectioning your contract.
Yeah, that's why Juan is saying that. Remember, when you deploy a smart contract, the blockchain is public, and anyone can call this function. So to avoid the spam, it's better to charge a little amount of near, like 1 octonier, to avoid the spam. Okay, we need to avoid someone is called create multiple calls from a function. So when we charge a little smaller amount, you need to authorize this transaction every time you're going to call it. That will avoid the spam or multiple calls for a hacker or someone with bad intentions.
Yeah, if we want to withdraw storage, we know we are calling this function, but we are not saying which storage or from who. Why? Because we can say the account ID or the storage that we want to withdraw, it's equal to the signal of the transaction. This is a secure manner to withdraw just your funds. The deposit that you want to withdraw, it's equal to we are asked for the key of your name, your account here in the storage deposits unordered map. So if you have deposited something, this will appear here and will be the amount that the smart contract will send to you. If you have nothing, then this called panic. So we are adding unwrap, or so this cannot panic. If you just add unwrap, this will panic if you have not attached deposit before. So we are telling smart contract, give me the amount of deposited from I don't know, Andres.testnet. If Andres haven't deposited something, then there is no field with his name. Then is equal to 0. And now we are going to assert it. So asking the contract again. The deposit is more than 0. If yes, we can continue. If not, no storage deposit to withdraw. Why? Because we are not going to create an empty promise or empty transfer of 0 nears. And just if you have something deposit. And let's storage in the transaction of the transaction a message. Again, we need to format the string with draw curly braces near.
Okay, guys, one comment here.
Yes.
Remember, as I told you, the first day, Rust is a low-level programming language like C. So you need to format all your variables. It's not like Python or like Java, where they do this task for us. We need to tell everything to the programming language we need to create. So for that reason, it's maybe annoying to format a simple string, but this language programming requires.
Yes. And now, if and now then we need to remove the key of the account ID because we are withdrawing everything. So self dot storage deposits dot remove the value with that key. That key is your account ID. Last, we need to send this value to your account. So we are going to use promise, the function new. This create a new promise to this account ID. If we don't write something here, it's an error. We need to write an account ID here. And the account ID is the signer. And then why we are creating a promise, we need to transfer the amount is deposit. Save the file, no error. And just in case of maybe you want to know the sum of the total deposits from everyone, a public function with get sum of deposits. In this, we just need self, not mood self, because we are not going to change anything in the blockchain. Just read a number. And this will return an unsigned 128. But why this using signet is with a U big? Because this is a JSON type, not a number type. It's something that you don't need to worry about right now. But in case you're returning something, this needs to be a JSON type. So we need to import this from use near SDK JSON type. And we see we have U64, U128. We are going to use this. And this function, this is very quick, or I'm almost Let's create a mutable variable inside this function. Call it sum. This is of type 128 equal to 0. And now a simple for function. For deposit in self storage deposits values. So we are asking read for the values, not the keys. So this is not returning the names, just the numbers. And for each of one values, for each of one of these values, sum is equal to plus deposit. And now we need to return. This is simpler to return and transform it or converted U128 with sum. Now we have four functions. The new that create the state of this contract, the payable function that deposit a near or more than a near, the withdraw function that returns that near, and the one that don't change anything, that returns just the total amount of deposits. Let's deploy it. Let me check the comments. Everyone has the NERCLI installed. Here. Yeah. Some of you. The other has not the NERCLI installed yet. Well, let's compile this contract. At this moment, we have not compiled this yet. If we try to compile, maybe no, for sure it will tell us we don't have added the WASP compiler. So we need to add with roast up target add WASP 32 you know.
This is the type of the compiled file NIR requires to run in the blockchain. That is doesn't matter if you're developing assembly script or Rust. This is the same format for both.
Yes. Let's click. And then here. Yes, if you click it here, you will see that it installed. If you have it installed, this will just tell you it's already up to date. And now let's compile. Compile with cargo build target was 32 unknown release. Why release? Because we it's why what we added here in the release version. Make all these changes.
Please, can you write it down in the command to compile the code, please, in the chat? group to share with the guys.
Okay. This one is this.
Yes, Timur, we're going to upload this to an open source GitHub file. Please, Juan, at the end of this session, can you upload this code to GitHub and share in the Telegram channel, please?
Yes, yes. Yes. Now we see everything appears with compiling, no errors. I think not even a warning. And now we see a new folder called target. Was 32 release and the was version. Again, this is something that maybe we will not read.
It's not readable.
But
this is the file we're going to upload to the blockchain right now.
Let's deploy it.
Okay, guys, to deploy, we need to log in to our NEAR account, or we can use a def deploy command. There is two main differences. When you use a def deploy command, each time you deploy your smart contract, all the information will be erased. If you're using an account, you can hold it. For this purpose, we're going to use NEAR deploy, and the command will return a def account create for each smart contract.
Yeah. The command needs the word near, the name of the command, the deep deploy, the ubication of the WASM file inside of target was 22, release near course.wasm. Click.
Can you share this command too, please, Juan?
Yes.
Okay, now it's NEAR making his magic, and we already have a smart contract deployed. There is a way we can see all the functions deployed in a smart contract. You can go to a site called Stat Gallery. I don't know if you can share one on the Stat Gallery site.
Oh, great, yes.
Okay, when Juan deployed this smart contract, we receive a def account. This def account you will paste here in this Stat Gallery, and you will see all the functions Juan just create.
So in its Stats Gallery, we can choose testnet. The name of the contract is, in this case, near gives us dep and all this number. Show stats. At the left, we see many options, contract, and we see the contract methods, new, deposit to storage, withdraw storage, and get some of the deposits.
Exactly. You can call this function from here or just from terminal. But I just wanted to show you that you can audit any smart contract calling the name of the contract here. This is a very useful tool when we're going to work with the blockchain.
Now let's initialize the smart contract. Okay. Let's show what happens if I want to call this function without initialize the contract. near get sum of deposit is a view function because don't modify the blockchain. So we use the word near view. You can see it bigger note. Near view. The ID of the contract is it's here. Space, the name of the function. And that's all. We'll see an error because it's not initialized. Yeah, an error occurred. The contract, it's not initialized. Okay. In order to initialize the contract, near all, because this function will modify the state of the contract. Near call, the name of the contract again is space new. Don't resave anything, just new. And the account ID from which we are calling. We are calling from Jeff. Click. We see it is calling transaction ID. To see transaction in the Explorer, please open this in your browser. I will send the link to you. And we can see it here too. We know the Explorer is an indexer running. Wait a few seconds and the transaction is here. Arguments, no one, because everything is take it from the environment.
Yes, you will see how many gas this function has used, sorry. And
5.
of course, any transaction is public. You will see the signature. The signature is one, yep, and the receiver is the dev account we just created.
And now let's try the function deposit to storage. I don't know if some of you can help me with this. If you have the CLI open. Let's share the code.
And after this call, we can finish for today, Juan.
If you want, we can leave it for tomorrow.
Yes, we can keep going tomorrow, but please just upload this source code to GitHub so we can study and understand how this works, and everyone can try to deploy it by themselves. And I think this source code could be the main base to your project.
Yeah, so tomorrow, everyone prepare your near CLI and let's try these functions.
Yes, maybe we can help you tomorrow to start your projects. If you don't know where to start, we can give you any ideas to what to do for this course. Let's find out the simple smart contract. Try to not go to the moon or create any financial stuff because we won't have enough time to deliver. But I think we can start with simple functions that you can create and understand. That is the main reason we are doing this, to understand the basic idea. Okay, don't try to build any complex function because just to understand Rust is a little bit harder. and understand how they work. What we need to you guys to understand how the blockchain works. So focus on this and not in to create something impressive. That will come later. Okay, Juan, I don't know if you are going to show any the last thing from this contract or
No, no, maybe tomorrow we can
okay.
see the deposit, the withdrawal in some minutes, not too longer this call.
Okay, awesome, awesome. Well, guys, we'll stop right here and thank you. Okay, Renzi, go ahead.
The project teams might be 4 people. 4,
Yes.
4, and 3.
Yeah.
3
Yes.
project team will be.
Yeah, sure, no problem.
Okay.
Well, guys, I hope you can understand everything Juan explained us today. I think that things can be a little bit harder is the variable declarations, this unwrap stuff, and how to build this together. But in the time when we're working as any programming language, we will understand. So, well, thank you to be here, guys, and in a bit, Juan will we share this code, and see you tomorrow. Okay. Okay, I'm going to stop the record.